All right, first four here are all kind of using the unit circle. So I'm going to go ahead and do number 4. So this one, it says cotangent of negative 330. Now, or sorry, negative 300. Whenever your angle is too big or too small to be on the unit circle, you always have to find a coterminal angle. So for this one, I'm going to add 360 to that, and I'm actually going to do cotangent of 60 degrees. So I go to 60 degrees now, and I know that cotangent equals x over y. And so I'm going to do my my x value, which is 1/2, over rad 3 over 2. I'll go ahead and multiply by the reciprocal there, so 2 over rad 3. And I end up with 1 over radical 3. You could rationalize that denominator, but on these ones, they do allow you to write it in with the unrationalized denominator, so you can just leave it like that. All right, next set here is kind of more of the same using the unit circle now. Now, I'll do some radians here. So for radians, whenever they're too small or too big, you have to add or subtract 2 pi to find the coterminal angle. Now, I would always do that with a common denominator. So on this one, I'm going to add 12 pi over 6 because you can see that reduces to 2 pi. Whereas on number 9, I'm going to actually subtract 4 pi over 2 because it's too big, and that has the common denominator but reduces to 2 pi. So this one's going to be tan of pi over 2, and this one's going to be cosecant of, let's see, what is that going to be, 5 pi over 6. So cosecant of 5 pi over 6, I would go to 5 pi over 6. We know that cosecant is the reciprocal of sine, so it is 1 over y, or it's actually just flip y, which is what I would do. So my y value is 1 over 2, so that's a nice easy flip to 2 over 1, which I would just put as 2. Next up for tangent of 5 pi over 2, or which I'm actually doing is tangent of pi over 2, I would go to pi over 2, and we know that tangent is y over x, and so this would be 1 over 0, which is undefined, which you have to write it out here. Remember, if it's a 0 on top, that's 0. If it's 0, 0 on bottom, that's undefined. All right, next up here, we're having to pick the correct quadrant here. So this is kind of all based on the all students take calculus trick, which means that out of the main 3 trig functions, all of them are positive here, sine is positive here, tan is positive here, and cosine is positive here. So for a question like number 11, when it says tan is, and I'm going to interpret this as being negative, and sine is also negative, I would build like the 4 quadrants, and then if tan is negative, I'm going to cross off these 2 because tan is positive in the tan quadrant, of course, and then also in the all quadrant. And then if sine is negative, it can't be the sine quadrant because sine is positive there, and so this has got to be quadrant 4. For number 12, whenever they give you one like cosecant, I would always kind of change this into its reciprocal, which in this case is sine. And sine is also going to be less than 0. Remember, it won't change the positivity or negativity if it's switched from cosecant to sine or any of those reciprocal functions. All right, so if they say sine is negative, which is what they're saying here, then we can cross off these 2 quadrants because sine is positive there. However, they also say that cosine is positive, and so if cosine is positive, it can't be quadrant 3. It's got to be in quadrant 4. All right, next set here, these ones. All right, we're going to build our 4 quadrants again. I'll just do number 14. So for this one then, what they're telling me here is that I already know that tangent is negative 5 over 3, since that's the reciprocal of cotangent. And so that also tells me that tan is negative. So if tan is negative, I cannot be in quadrant 3 or quadrant 1 because in both of those tan is positive. And it also tells me that cosine is positive, so I would say that's got to be in this 4th quadrant right there because cosine is negative over here. Now they tell me if this is theta that I'm going to use the tangent version, that it's 5 over 3 for the tangent, or the cotangent. Adjacent over opposite is 3 over 5. But they don't tell me which one is negative. It is implied there that one of those is negative, and so I'm going to say on this one, the 5's got to be negative because it's going down, whereas the 3 should be positive because it's going to the right. So be careful on those negatives. You never really know if it's applying to the top or the bottom. Okay, so now I need to Pythagorean for the 3rd side here. It's not a 3, 4, 5 right triangle because the hypotenuse would have to be 5. So I'm going to do it like this. So 9 plus 25 equals c squared. So that would be 34 equals c squared, and we will square root that. And 34 breaks down to 17 and 2, but that's it. So nothing I can take outside. So I'm just going to call this rad 34. The hypotenuse is always positive here, so I don't need to check the direction on that. If I'm finding a leg, I kind of do. All right, so my sine then would be opposite over hypotenuse. That's -5 over radical 34, and you can just leave it like that. My cosine would be adjacent over hypotenuse, so that's +3 over rad 34. And then my cosecant is flipped over sine, so that's -rad 34 over 5. And my secant is rad 34 over 3, which is just a flipped over cosine. All right, number 15 is really the same as the previous question, so I'll let you guys try that out. All right, next up here on both of these, they're giving us the area of each sector is 14. They're asking us for the radius. So my area formula is pi r squared and then times whatever fraction of the circle I'm looking at. And so in this first case, actually I know the area is 14 pi. Oh no, it's not 14 pi, it's just 14, excuse me. And then I have pi r squared here, and I don't know r, and I know that this is going to be 0.6 over 2 pi. It's over 2 pi because when we're talking radians, the whole circle is 2 pi. So now I can cross off these. I'm going to multiply each side by 2, so 28 equals r squared times, and I'm actually going to see this as 3 over 5, or 6 over 10 if you like, but I'm going to see it as 3 over 5. So I'm going to multiply by 5 over 3. And that does not cancel out, so I just get that r squared equals, that's 28 times 5. 140, so 140 over 3. And then I would square root that, which I'll try to do a little more neatly there. Okay, and I know I can't break down the 3, but I think I can break down 140, so I'll do that up here. So that would be 14 and 10, which is 7, 2, and 2 and 5. So I actually can take out a 2 out front. So I'm actually going to say r equals 2 rad, and then 2, and then I'm going to keep this in a big radical, 35 over 3. Just because I can take that 2 out front, so I prefer to do it like that. All right. So again here on the second part, they're telling me that the area is 14. And so I'm going to set 14 equal to pi r squared, and this time the fraction of the circle that I'm looking at is 100 over 360. I'm going to right away reduce that, and then I can reduce it by another 2 here. So I'm going to say pi r squared times 5 over 18. And so now I'm going to multiply the reciprocal over. And so 18 times 14. And that is, so that'll be 252 over 5 equals pi r squared. And then we will divide by pi, which on this side I would look at as multiplying by 1 over pi, so it's going to go on bottom. So I get 252 over 5 pi equals r squared, and then I'll just square root both sides. You should be able to write it in just like that. So the square root of 252 over 5 pi. All right, next up here for number 17, so it says find the length of an arc. So it's arc length. So remember, arc length is related to circumference. It's 2 pi r, and then we multiply that by whatever fraction of the circle we're looking at. So they are telling me here that my radius is 4. Oh no, the radius is 3, and then I have 4 radians in here. So radians are out of a total of 2 pi. So right away I can cancel out these 2 pi's, and so I just get s equals 12. Nice and simple. All right, next up, these ones, I am going to use my area formula. Since it's asking for the area, it's going to be pi r squared times whatever fraction of the circle you're looking at. So for this one, I'm going to replace the r with a 6, and then we're looking at 74 out of the total 360. So area equals pi times 36 times 74 out of 360. And I see now that this is really easy to simplify this way and turn this into a 10. And then I can reduce this by 2 with this. and that is going to make that 37. And so this is going to come out to 37 pi over 5. Next one here is going to be very similar, except instead of multiplying the pi r squared by theta over 360, it's going to be at a 2 pi because we have radians here. And on this one, our radius is 15. So area equals 225 pi. Oh, actually, I'm not going to write that pi because I can cancel those out here. And then times 0.4 over 2. So I'll go ahead and do 225 times 0.4. So that's 8, 9, 10. That's 9, and so that's 90. And so that's 90 over 2, so that would be 45. All right, this next one asks you several pieces. I can't see all the pieces here, but I know what they say. So for step 1, it asks you for the formula for a triangle, for a non-right triangle here. And so we did learn this in class, that the area of a triangle is 1/2 AB sine of big C. And that's step 1. Okay, so then step 2 asks an equilateral triangle. It has all the sides that are equal. And so all their angles, if you think about it, would be 180 divided by 3, since it's dividing those 3 angles up evenly. So that would be 60 degrees. And so then for part 3, if you kind of visualize this triangle here, all the angles are 60. All the sides for me are 11. They're probably different for you. Then this formula turns into 1/2 times 11 times 11 times sine of 60. Now we know that the sine of 60, according to the unit circle at that spot right there, is rad 3 over 2. And so I can replace this then. Actually, I can multiply these two together. So 121 over 2 times rad 3 over 2, which I would just say is 121 rad 3 all over 4. Since we're multiplying that, we have to multiply the common denominators together. Then it asks you to so that's kind of part of your answer there, and then it asks you to do a decimal. So you are, for the last step, going to have to change that to a decimal, and that will be the only thing on this you'll use a calculator for. All right, this first piece here, they're wanting you to put kind of the definitions for how we find amplitude on this one. So on that one, the amplitude is always the absolute value of A. Remember, it has to be positive. And then the period is going to be 2 pi over K. The horizontal shift is going to be B. That's like the phase shift there. And so on this one, for me, I have a amplitude of 3. A period of 2 pi over 9. Remember, it's not 9, it's 2 pi over K, and I have a horizontal shift of pi over 3. All right, here's another multi-step one. So for step 1, they ask you for the amplitude, and so the amplitude on this one I would say is 1 because there's no number multiplying in front there, and the period is 2 pi because there's no K value. Step 2, it asks you about the shift, and so I would say that this plus 3 out front means it's a shift up 3. And then so part 3 asks you to select the correct graph. So make sure you do one that has a shift of up 3 or up whatever yours is, and then is a sine graph. All right, next up here, they want us to graph this function. So I see right away that the amplitude here is 2 because it's the absolute value of that. Now all of these look like they have an amplitude of 2. And so what I'm going to see here is that this is a negative sine graph. Now normally a sine graph starts at a midpoint and goes up, but a negative sine graph always starts at that same midpoint and goes down first and then up. So with that, I would say it has to be this one. Next up here, they want us to graph this one. Now on this one, I'm going to say the amplitude is still 1. And what this is up here is a down 5 shift. And so I would say it can't be either of these two. Those are up 5 shifts. And since it's a cosine graph, cosine is going to start at the high point. And so the high point is going to be this one. That's like the middle of the graph should be a high point, and so I'm going to say it's this one. This one would be negative 5 plus, or this one would be negative 5 plus sine of x. It's starting at that midpoint. All right, number 6 here. First of all, the amplitude on this one would be 1 because there's no number multiplying in front. The period would be 2 pi over 4 since that's our k value for me. But that would actually, I would reduce it to pi over 2. Now it's a cosine, so it should start, it's a positive cosine, so it should start at its highest point. So I already know it's not that one. And it's not this one. Those look like negative cosines. But with an amplitude of 1, I would say it has to be this one. And you can also see this period of pi over 2, that distance from there to there. All right, next one here again has an amplitude of 1. Now the period here would be 2 pi over k. Our k is actually 6 pi here. That's the number multiplying by x. And so if I cancel those out, period is actually 1/3. So it's not 1/3 pi because the pi's cancel out. It is actually just 1/3. And so with that, I'm actually going to say it's this one right here because you can see it starts at 0 and it goes to 1/3, which is actually what we want to do. So don't be confused by this one, pi over 3. That's not what we're looking for because the pi's canceled out. All right, next one here, we know our amplitude is 7. Remember, the amplitude must be positive. Looks like all these, oh no, this one does not have an amplitude of 7, so I can cross that one off. The period here is going to be 2 pi over 6, which is pi over 3. And so it's a negative sign. So negative sign starts at its midpoint and goes down and then up like that. So I'm going to cross off this one. That one starts at a midpoint and then goes up. That would be a positive sign. It could be either one of these two, but with a period of pi over 3, it's got to do one full down and up and then finish at pi over 3. So this one's looking really good. This one takes 2 pi to do that whole cycle. All right, next up here, this one again has an amplitude of 5. The period on this one is 2 pi because we have a k value of 1. And then I have a phase shift of positive pi over 6, which is going to move it to the right, pi over 6. So I know my sine graph, let's see, it's a negative sine graph though, so it's going to start at its midpoint and then go down and then up. But it's going to get shifted to the right by pi over 6. So I want to look for one, it looks like here, yeah, that's it. So it got moved a little bit to the right and then goes down and then up from there. And so that is my graph. All right, next one here, we've got our amplitude is 5. Period is 2 pi. And this one, our phase shift is actually negative pi over 2. It's always the opposite of any adding or subtracting in there. So my positive cosine, it normally starts at this high point here at 0. But in this case, it's going to get moved to the left by pi over 2. So I would say that's got to be this one, starting at negative pi over 2. All right, next one here, I think it's really easy to see. The amplitude is 1. The period here, we do have a k value multiplying by x, so that's going to be 2 pi over 2, so that'll be just pi. The phase shift here is a little harder to see because we have a number multiplying by x. On this one, for the phase shift, we need to take the whole inside and set it equal to 0 and solve. So 2x equals negative pi, divide that by 2, and so x equals negative pi over 2. So we know our sine graph, usually it's a positive sign, starts right there and goes like that, but it's got to be moved to the left by pi over 2. And so it should be starting at that midpoint, going up at negative pi over 2 like this one right there. So that's this. All right, next up here, we're going to graph one complete period of sine. And so the amplitude, you can see it goes up to 6 and down to negative 6. That's an amplitude of 6. The period is 2 pi. The horizontal shift is 0. It's kind of starting in the correct spot. And so I would say this is 6 sine of, and a period of 2 pi would mean that k is just 1. So I'm just going to call it x. All right, next up here, we're graphing one complete period of sine. And so I can see right away the period is 6 pi. The amplitude, it looks like, is 9. We have no horizontal shift. Now for this one, the k is a little tougher to see. So what I would do is I would set the period equal to 2 pi over k. Remember, that's how we always find k, is 2 pi over k. So I'm going to set the period equal to that. I'll go ahead and cross multiply here. So 2 pi equals 6 pi k. I'm going to isolate k, so I'm going to divide by 6 pi. And so k equals 1/3. And so I'm going to write this as 9 times sine of 1/3 x. All right, next up here, they have a cosine graph. It looks like the amplitude is 1/5. You can go up, down 1/5. The period on this one, it's kind of it's this distance right here. I would always subtract the end point minus the start point. Now in this case, that's going to be subtracting a negative, so that is 3 pi over 3, so that's just pi. We do have a horizontal shift here. I think they're wanting me to start right here, so I'm actually going to say that this is actually going to be a negative cosine since it's starting at a low point. And so our horizontal shift is negative pi over 3. If our period is pi, that means that k is 2, because 2 pi over 2 is going to give me that pi. And so I'm going to say this one is 1/5, actually it's negative 1/5 cosine. And once again, it's negative because it's kind of upside down, starting at the low point, but the amplitude is still a positive 1/5, but I put negative 1/5 in front. Put 2 here, and then parentheses x plus pi over 3, since the phase shift is always the opposite. All right, this next one here, they did a bad job of labeling this. I'm going to say that this is negative 2 pi over 4, or negative pi over 2, and then this is negative 3 pi over 4, just to kind of keep consistent with this scale right here. And so with that, our phase shift is negative 3 pi over 4. It looks like our period is pi, and then the amplitude is 1/15. So I'll let you guys handle it from there. All right, next up here, we got an amplitude of 7. The period on this one, going from beginning to end, is 1/4 minus negative 3/4. And so that period is 4/4, which is actually 1. This period does not have a pi in it, and that's okay. Our phase shift is left 3/4. And I need to find k now, so I'm going to say the period equals 2 pi over k. And if I multiply with a k over, it would say that k equals 2 pi. And so that's it. I've isolated k. And so what I would write on this one is, and I would say it's a positive sign since it's starting at the midpoint and going up. So we have 7 sine. The k value is 2 pi, so I'll put that there, and then a parentheses, and then x plus 3/4. All right, next up here, number 23. So for this one, it says a triangle has an area of 15 square inches and two sides of the triangle of length of 5 and 7. All right, so we're going to use and it says find the sine of the angle included by these two sides. So we know our area of a triangle is 1/2 AB sine C. And they're actually not asking me to find angle C. They're actually asking me to find sine of C. So let me just plug in everything I know and kind of go from there. So I'm going to say 15 equals 1/2 times 5 times 7 times sine of C. I'll go ahead and multiply the 2 over to this side. So I get 30 equals 35 sine of C. And I'll divide by 35. And so I get sine of C equals, I'm going to reduce that to 6/7. And so that's actually my answer. Sine of C equals 6/7. You can see once again, they're not asking you for theta. They're not asking you for C. They're asking for the sine of C. All right, next up here, we got an area formula. So area equals pi r squared times theta over. And they say they want this in radians. So I'm going to put that as 2 pi. I'm going to go and cancel out those pi's right now. I'm going to plug in this as 1400 equals 40 squared times theta over 2. Got to do my PEMDAS here, so this is going to be 1600 times theta over 2, which I'll just call 800 theta, equals 1400. Divide by 800, not 8,000. And 14/8 would reduce to 7/4 equals theta.